Have you ever wondered how the body keeps up with the ever-changing conditions, say when you are feeling too hot, when you had a sugary meal, or what really happens when you have a wound? The body just does it all. And this is all possible because of its ability to maintain stability through a process called homeostasis. Homeostasis is a process that ensures internal conditions remain nearly constant despite external fluctuations and changes. The two key ways these are done are through something called the negative and positive feedback mechanisms. Now, what exactly is a negative feedback mechanism, and what are the key elements that make it work? A negative feedback mechanism is a control loop that is most commonly used by the body to maintain homeostatic balance in the body. When a change occurs, the body makes adjustments to ensure that things go back to normal. Think of it as a seesaw, where if one side tips too much, the other side moves to bring it back to balance, which in this case is the mechanism of negative feedback loop. This loop is composed of four key elements: a stimulus, a sensor, a control center, and an effector. The stimulus is the initial change that disrupts balance from a stable condition, which then activates the feedback loop and signals that something needs to be adjusted. The sensor, or also called the receptor, continuously monitors the stimulus and changes in physiological values, transmitting such change to the control center. The control center, in turn, is responsible for determining the appropriate response as it evaluates the detected physiological value by comparing it to the normal range. The main control center of the body is the nervous system. Lastly, we have the effector, which may be an organ, gland, muscle, or any structure that will respond to the signals sent by the control center, ensuring that the physiological value will be restored back to normal. In addition to this, your body also relies on two important communication pathways, the afferent pathway and the efferent pathway. First, we have the afferent pathway, which usually occurs when signals travel from the receptor to the control center. You may think of this as a way of reporting a change. Another is the efferent pathway, which will occur when the control center processes the information and sends signals to the effector to carry out the said response. And just like that, with the interplay among these components, your body successfully achieves homeostatic balance. Let us see how the body makes use of this feedback mechanism to achieve balance by understanding how these components are applied in real life. Imagine it's a hot day, and you're walking. Suddenly you feel hot, and your body temperature rises above the normal 37 degrees Celsius. This rise in body temperature is the stimulus, and this will be detected by skin receptors or the sensor, which will then be sending a signal to the brain in a communication called the afferent pathway. The brain, which is the body's control center, will now process information and will decide what action is appropriate, which in this case is to cool the body down. The brain will now signal the appropriate effectors, which are the sweat glands and the blood vessels, sending them information through the now called efferent pathway, which in response will cause the sweat glands to release and produce sweat, and the blood vessels to widen or dilate. Both of these will cool down your body, and just like that, your body temperature is back to normal. Now, what happens within the body after you eat a big slice of cake or drink lots of sugary soda? Your blood sugar levels rise above their normal range. A stimulus of an increased blood glucose level will be detected by the receptors in the pancreas and will send a signal to the pancreas itself, which is the control center in this situation. The pancreas will recognize the said changes and will decide what will happen next, which in this case is by releasing insulin, a hormone that will help lower blood sugar. In turn, the insulin will command your cells in the body to absorb glucose and will send signals to the liver to store excess glucose in the form of glycogen. This will result in lowering your blood glucose level back to its normal physiologic level. Now we move on to the opposite process, the positive feedback mechanism. It is a control process where the output enhances or reinforces the original stimulus, continuing to do so until an external event stops it, which results in a more extreme physiological response. Imagine a rolling snowball down a hill, which gets bigger and bigger as it collects more snow. This is just like a biological process that keeps amplifying the stimulus. Like the negative feedback loop, this also consists of a stimulus, sensor, control center, and effector. The only difference is that instead of reversing a change, the effector strengthens the original stimulus. A critical example of positive feedback is demonstrated during blood clotting to prevent excessive blood loss from an injury. When a blood vessel is injured, platelets in the blood detect this damage, acting as the sensor. They then release chemicals that attract even more platelets to the site of injury. In this way, the response is amplified, causing a rapid accumulation of platelets that form a clot. The growing clot, which is the effector in such a scenario, continues to expand until the wound is sealed. This then stops the loop, causing now the normal regulatory mechanisms to take over to ensure that this clot does not grow uncontrollably. Now, what exactly is the point and significance of the occurrence of these feedback loops, and why do we need to learn all this? The said mechanisms are significant for the maintenance of balance of your body conditions and will ultimately be important for your health, stability, and survival, because without them, your body would not be able to function properly, given that the body is forever exposed to extreme fluctuations. To summarize what was learned here, negative feedback loop is the most used control mechanism of the body to achieve balance immediately without turning such changes into big problems. Moreover, the positive feedback loop is also essential for the body's survival and functioning. Negative feedback also keeps physiological conditions stable, while positive feedback helps the body complete necessary processes efficiently. And there you have it. The next time you sweat on a hot day, or you feel normal after eating a heavy meal, you even have your wound healed in time, you can say thanks to the process of homeostasis and its feedback mechanisms. If you find this video helpful, don't forget to like and share for more contents. Remember, stay curious and keep exploring. Thank you for watching, and see you on the next one.